Okay, hi everybody. Last video of this unit, which means it's our last chance for our video flipped classroom. And I'm just going to give you a very brief video on review. So the idea today is to kind of sum up everything that we've done this unit. We'll definitely be talking in class as well and looking at the things that we've done. What I did was I did a very quick little sheet of everything we've done. So we started with all kinds of factoring. We're still doing factoring because this whole unit is all about quadratics. You have to know GCF dots trinomial, grouping, which is the four-termed thing. When you have four terms, something that looks like this, minus 2x minus 2 or something. When there are four terms and we do a GCF of just two at a time, so here we would GCF 2x squared and do x minus 1. Here we would GCF a negative 2, and let's say we have x plus 1, shoot. Let's pretend this was a plus. And then the one that came in common gets written just once, and the other stuff gets set into the other parentheses. So those are my factors there. You do not need to know the difference of sum and difference of cubes. But this one is the grouping. Grouping is the four-term one. The hard trinomial with the number in front. The higher power just means what if you have an x to the fourth minus x squared minus, let's say, 72. Oh, I would factor like normal. What multiplies to 72 and gets you to 1? It's 9 and 8, but when you go to do the parentheses, you put an x squared in each of them. Minus 9 plus 8. And then, of course, this would do dots and could break again, but the other one could not. So those are all kind of things we did in Unit 1, but they are all reviewed here. You should be comfortable with all of those. And then this little asterisk also set to 0, which means know the difference. If this had had an equals 0 on it, and an equals 0, and it was going down equals 0, then you would need to draw these lines and set each piece to 0. If there's no equals 0 and it just says factor, you stop when you factor. If the quadratic does not factor, you have two options: complete the square or the quadratic formula. Quadratic formula is the one that has the Pop Goes the Weasel song. X is equal to negative b plus or minus b squared minus 4ac all over 2a. Gotta know that. Complete the square is the one where you move over the constant term. Let's say it was a 5 or something. Cut the middle number in half and then square it. Half of 20 is 10. 10 squared is 100. That would be the number that you add both to here and to here. You end up with 105 on this side. You end up factoring to x plus 10, x plus 10. And because we got two of them, then we write x plus 10 quantity squared equals 105, and then you do a square root of each side. This, remember, is just a very brief review. So if any of these topics are something that you still don't understand or that you need practice with, you should get in. Because academic support has not been super busy, so I would be happy to give you some extra example of complete the square or quadratic formula. But these are both things that let you solve quadratics when they are not factorable. In addition to that, we had 2 different days. Discriminant, which is just the b squared minus 4ac part. That was all about describing the roots, like real, rational, unequal, imaginary. And then the 2 small formulas, c over a, negative b over a, to find the sum and product. So if they ask you to find the sum and the product, you just use the formulas. If they ask you to work backwards, you take the 2 roots and add them and multiply them to come up with the equation ax squared plus bx plus c equals 0. And then the last couple of topics, the parabola with the new vertex form, which means if you see something like this, x minus 7 squared plus 1, you should know right away that the turning point or vertex of this is 7, 1. The axis of symmetry is x equals 7. So the idea was we took this and this coordinate, but this one switches sign, and this one does not. So this entire parabola, without a graphing calculator, would move over 7 units to the right and up 1. So over 7, up 1. And of course, it's going to be a smiley face because there's no negative here. So basically, the parabola would look like that. And then the equation of a circle was our x minus h squared, y minus k squared equals r squared. You have to know how to put the center in and also find the radius when you're given a point that the circle passes through. And then the last thing, the two systems of equations, two equations solved simultaneously. You can do that graphically or algebraically. Graphically, it could be two parabolas, it could be a circle and a parabola. Suppose they asked you to graph a circle and a parabola, something like that. You'd find points of intersection. But more typically, it was a parabola and a line, or a circle and a line graphically, or algebraically. If it's algebraic, you have the choice of substitution or elimination. So that's it in a nutshell, this discriminant. I forgot one more quick thing. Here for this discriminant, you do need to memorize this thing, that if the discriminant is a negative number, this means negative, it means imaginary roots and the graph would not touch the axis at all. If the discriminant comes out to be 0, that means real, rational, equal, and the parabola would just barely touch the x-axis. The first two are a perfect square, a positive number that's a perfect square, a positive number that's not a perfect square. Both of these would hit the x-axis twice. But the one that's a perfect square will hit right on an exact ticky mark, and the one that's not a perfect square would be right in between. All right, so that's it for today. Please stop in if you have any questions or problems, and study, review for our test. I'll see you next time. Bye.